Hi, welcome to week 6. In this week we are going to see some exercises regarding pops. I won't make any renders. We will do a ground explosion, some particle kicks from a character while it walks, and finally I will show you the attract node inside ops. So let's get started. As I told you, I won't make any render because we won't have time to see everything this week. So let's save our scene. Let's start by explosion, and let's name it as English. Okay, we are going to start from our geo node, and inside I want to create a cylinder or a tube. We'll make our radius a bit smaller, and also I want to add end caps. Also switch our primitive types to polygons, and what I want from here is to get only this cap, so we can delete and click non-selected just to keep our cap. I also going to make this smaller and also transform so we get our polygon just in the floor. So this is our emitter. Delete. Let's or keep cap. And what I want to do now is to add one subdivision level. Because I want to play with the vertex in the center. So this means that let's click this guy again. So this will give us the direction of the explosion. If we get this point higher, we'll get an emission, just a wider emission. If we get this guy down, we will get a taller emission. So this will be good to add some variations. Let's keep it a sedation point, and we will tweak it later on. What I want to add are our normals. So we set up our direction, okay? But what we see now is that our normals are just where we have vertex. So a good idea for this is to add another subdivision level. Now we have a better emission all over the surface. This will allow to have different velocities depending on the place where the particle will be emitted. Add extra detail, add normal, okay. And now, as we did the previous week, I will create a point bob to create some random on our normals. so we get different velocities. So let's plug our turbulent noise. And let's multiply this value. Remember always to set, at least for normals, 3D noise. So we connect position to position and the result of the noise to our multiply node. And I want to multiply this by the normal attribute that we have it here. I want to show the result in the normal and also in our velocity, because we will use velocity later on in the pops. Okay, now it's just a matter of tweaking a bit the frequency, set the amplitude, and probably a bit more of roughness. So okay, now we have smaller normals here and larger ones. This will give us a nice variation on our mission. Now, if we get back to our extra detail, to our editing point, we'll see how our normals change or the direction. So we are able to get a better emission, more controllable. So now it's time to add our pop network. Let's save this. Explosion parts. We already have some particles there, and let's see what happens. Okay, we have different velocity particles. Going down, but well, what we want to do is to animate our mission. Let's learn how to do that. Inside the birth you have a constant activation. This control 1 is turned on and 0 is turned off. So if 1, the constant birth rate will be 5,000 particles per second. We only want to emit particles in our first 3 or 4 frames. So let's add a key just by hitting Alt and left mouse button. We see how our attribute turns into green. That means that we have a keyframe on that. Let's move to frame 4. Let's set this guy to 0, and again let's Alt and left mouse button here. Now we have a keyframe from 0 to 1. If you want to see our curves, you just hit Shift and also left click button, and if you hit G, you will see our curves from our attribute. You can change the tangent positions, but right now, as we have a value from one frame to the other one, we don't need any easy in or easy outs. We can also change the interpolation mode right here, but I'll keep this simple now. We will work a lot in the future. Okay, now we see we have our mission, that's right. We will add some gravity. And we will also make this a bit shorter. Let's set up the max keyframe 250. And also turn on the real-time toggle. And now what we want to do is just to add a bit more of initial velocity. Also, what we can do is add our pop property. I do this almost all time because it's nice to get different velocities and different mass attributes per particle. So I suggest you to use it as much as you can. Nice one. So you can also add some turbulence, pop, wind, and probably a big swirl, and keep the pulse length because I don't want the particles to dance. So let's add turbulence here and mass random. Ignore mass, also remember to turn that off. I don't like this, so probably reduce a bit. I think that turbulence in this case is not working that good. It's just adding some, you see that the particles emit and like they stop because of the air resistance. This is the like an air density. So you should keep this guy low to get better results. But if you get this guy in 0, you won't get any of this noise happening. So it's a balance between air resistance and the noise amplitude. Okay, that's not that bad. So let's save this. I would like to add ground plane just to make these particles collide. But I don't want, let's organize this, but I don't want them to slice, just to stick. This is an effect that you can use it for far away simulations. This won't work that good on a close-up. Probably in a close-up the best way to solve this is to use rigid bodies with particle emissions and also some dust. We will see this during all the progress of this training, so don't worry about this now. I'm just want to show you some easy and fast setups so you get used to pops, and well, it can save your life, and they are fast simulations. Just use them far away, no close-up. So the collision while the particles land is not accurate, but it's enough for a far away simulation. Let's stick it to ground. We can probably add a bit more of initial velocity. And what I told you before is you can edit this point you see the higher this point is, you get a side, like a lateral emission. If this guy goes down, you get a higher. Okay, let's add probably was an extra second. And once we are glad with our result, remember we have to delete the ground. And you set this as primitive and pattern, click every single primitive. And now what we can do is copy stamp and create, I don't know, a cube, sorry, a box. Make it small. Let's call instances. Here we have our cubes, so let's make them way smaller. And what I would like to add now is some deformation, so let's add a point bob. And as well as we did the rock generation, yeah, in fact you can use the same rocks also later on in the model of rigid bodies. We will see how to generate some nice random pieces of rock. We can make them from a Voronoi fracture or the Boolean fracture. We can model some nice shapes and use them later on as instances. Right now I'm going to do some quick debris, just to have in mind, but we will see this later on in a better way. I'll guess in next model. So we need a turbulence noise. We need displays along normal, and just plug position. This noise goes to mount and display to position. What I want is to display the cube that we already have. Just to adjust, let me see what happens. Okay, this will be our different rock size. We can probably make this a bit bigger, and I want to promote this parameter just to add a stamp attribute. Now we have rocks the same size, so let's add a stamp input. Let's call this offset, and okay, what we have been working, the same expression, random to the points and 0 and let's say 100. And our stamp, let's call our copy node, our attribute, and finally a random number. And I want this guy for our channels. Something's not working. Oh, okay. I close the copy, and you shouldn't do that. Okay. What we can also add is a global transform for all our particles. And also we can add some details. And we can multiply, we can add a bigger particle emission. That's a lot, not that much. So let's see now. What do we get? Well, probably it's a bit big explosion, but well, it's just a way you can see how you can use pops in different situations. You can play around, make different emitters. The possibilities are a lot. So, okay, this way we have our first exercise done. So next exercise will be an effects added to a character while it walks. It kicks some, I don't know, it can be sand or rocks or dust or snow, whatever. Let's save this and let's start a new scene. Okay, what we will do, let's first save our scene file. Let's call it character kicks. I left you a folder where you have an XBX. You can import just by hitting File, Import, FBX format. You can go to your heap and export. You have a zombie walk. Just leave everything as it is and click merge. If you click import, it will create a new scene. So by clicking merge, it will add it to your current scene. So the XPX is imported, and you will see you will get always that you import an FBX, you will get this different node. It's very different to the other ones. It's a sub network. This means that inside there's obviously a network, but you have also different connections. If you dive inside, you can see that you will have a rig. You will have joints. They are all animated. You also have the character geometry. These shops are the animation curves, materials. You have everything inside. The best way to work this is to object merge or reference this object to a new Houdini node. This will keep your stuff clean and tidy. So let's add a geometry that will be our character effects. And you can object merge. Other thing that I'm going to do is this character is huge. You will see the grid is pretty small besides, so I want to make it really small. That might work better. So let's go inside our object merge, and I want to pick my FBX. Right now I have a warning. This warning says invalid sub-specified. This way we are trying to import a subnet or a group and not the geometry inside. If we dive inside, this guy will see that we have the body, the bottom, the lashes. We have different elements, but we cannot bring everything at the same time. There's a way to do this, just by going one level up and hit the start. It will bring you to your scene the entire character. It didn't obey to our scale. That's why inside the transform we have to put it into this object. So right now, and if we hide other objects, we will see our character. So now we are good to start. We can hide this guy. Reference model or reference character. And the first thing I want to do is to convert these to polygons. What I will do next, I want only the fits, because these are the guys that will do all the magic. We will generate a velocity attribute from this fit, and once the velocity is over a certain value, it will emit particles. So let's select our fit and delete. I'll do first one side and then the other one. This is right. And that click, non-delete. Okay, now we have what we want, our geometry. And what I will do next is also add a geometry, a polygon, just where our character will move. So let's create a grid and set the size to where our character is. It starts there and it finishes right there. And what I want to do is to add a lot of subdivisions. You will know shortly why. There's a node attribute in Houdini called the transfer node that you can transfer by position an attribute. So what I'm interested now in doing is to creating a color attribute. Let's say red, so we have a better idea. We see better what's going on. And this is our floor geometry, and we will add a black color. So right now we have our red feet and our black floor. Let's add this transfer attribute transfer. And as I told you before, this by distance will transfer an attribute. Right now we need the color attribute. So we click here from where we will get that attribute and the destination. If we click our display flag, here we will see right now our floor is completely red. Two things. First, what we are going to transfer. Right now we will transfer all our attributes. If we want, we can also set it to points, to color, to our color attribute, and inside condition, the distance threshold, you have the distance that this will affect. So let's template, and now we will see that our feet is transferring the attribute to the floor. This will be great to generate our footprints. Probably the distance is high right now. Let's set it down because we only want color right there. Perfect. Okay, now we are glad with this. What we can do is delete the black area. So remember, you can do this by expression and $CR. Now we want to invert, and what I told you regarding subdivisions, if you get more divisions here, you will get a nicer detail on our footprint. So let's see what we get. Okay, we are glad with that. So now, as we've done in the previous class, I will add some normals. to our points. And I want to add some random, but only in one channel. I don't want to add on X and Z. I only want to add on Y axis. So let's see how we do that. Random Y, normal. So if we want to add normal in all channels, as we always done, we have to repeat this process. There's some visibility stuff happening there, so no, it's okay. Just go to the object level if you have an issue. And we can add some frequency. And we will see a way. Right now we are getting the result to our 3 axes. If you hit here, you will see that your product is a vector. You have 3 channels, X, Y, and Z. You can convert this channel from from vector to float, and from float to vector. There's a node that does that, called vector to float, and what it does, it inputs a vector and it outputs the 3 different float attributes. And you can set it up again to vector, so you can plug it to our normal. And let's make a change here. Instead of a multiply, let's add, and let's see what's the difference. Okay, but that's not what we want. Let's keep this simple. Let's just see what happens if I don't want to multiply to our normal. I just want to get some nice normals in different directions. So that's what I wanted, just to get some diagonals. But what I told you is that we can't separate into channels. Right now we can manage our X, Y, and Z. So let's see if we add other channel, what happens. We have different directions. Right now I only want on this probably a bit of here. So what you can add is a multiply constant, and multiply this value and get a slight version of this channel. Okay, we are good until here. Let's add our pops. And let's see what happens. Okay, we have a particle emission. We have no inherent velocity just because we didn't plug it. Okay, we have some particles going up. So the first thing I'm going to do is to add a gravity. And also we will need a bit more of inherent velocity. Okay, a lot of bad things are happening, but I want you to see what's going on. Okay. We have a particle emission. We have it the contact on the floor. But well, when the feet is not moving, it doesn't have any velocity. We see that the particles are emitting. There's a procedural way to do this, so animate it. Let's go for the procedural one. What I'm going to do is to get this fit. It's right here, and in the geometry spreadsheet we'll only have a position. There's a way to add velocity to a vertex. The way to do this is by adding a node called trail. And inside a result type you can compute this as velocity. So right now we have from each vertex our velocity. So we will be able to get from this, when the feed has no velocity, no emission. That's why we have to connect it to our emitter. Let's put create velocity, and to keep things tidy I will add null. Right feed velocity. Okay, what I want is to get this attribute to our particles. We will constant activate this attribute by adding expressions. There's an expression where you can call a point from other place, set the number of point, the attribute you want to import, and use that value for emission. How you write that down? This point expression, and what I want to do is to get our fit. Let's dive into object level. Then you need to go to our character effects. If you select and hit tab, it will auto fill. And now what I want to do is to get our outright fit velocity. And from here what I need to put is our vertex number. You can use whatever number you want from that feed. That feed goes from 0 to, let's see, from 0 to 401. So in that range you can get whatever point number you want. Let's say 34. Let's add a comma, and the attribute that I want to import. In this case is velocity in all channels. And finally you get a value, a startup value. Also, another thing that I'm going to use, I only want to use this content activation, no impulse activation. So I will get this guy in 0. We see we don't have any emission right there, only one. Let's see what happens if we click our left mouse button here. We'll see our constant activation value. We can see that it's a pretty low value. We are getting values under 0.1, and to get it activated it has to be 1 or over 1. So what we can do is edit our expression, just add a multiplier to increase this result. Let's multiply by 10. Okay, something's working better right now. Save this scene, and the next thing I'm going to do is create a ground plane for collision. And let's see how this works. Okay, again we have our particle slide. Remember, you can tweak that from friction, or for now, to keep these things simple, I will add the heat attribute, and let's stick it to our surface. Okay, one thing that I notice is our particles are going just up in y direction. So what we can reuse is our expression and put it into our inert velocity and add an inert velocity. Let's keep this in 1. Also we can add another axis, just very similar to the rain. Okay, so this means that if the velocity is faster, the feet move faster, the particles will go up a bit more. Sweet, so we have our particle emission while the character moves its feet. So what we need now is to make the other feet. So let's first get our other feet. Let's call it and this is easy. You only have to duplicate network. Let's change our name to left. we will reuse all this stuff. I'm not going to generate again a floor because we can reuse the connection. And let's move this a bit down just to get things organized. The only thing, the two things, let's rename also this guy. And we have to change our velocity to our left. And also our birth contact activation. Okay, so now let's see if this guy is working as we want. Yeah, that's not bad. You can probably add a bit more or different emission. I will keep it this way because we have another exercise to make. So I want to bring also my character and both particle emissions. Then what you can do is to instance some particles in there. So right now we have our particle emission while our character walks. Nice. Let's save this and let's move to our last exercise. Okay, the last exercise of this week will be, I will show you the attract option node in pops. What I will do is I will I will materialize an object. Let's add let's save this as attract English. And what I do first is add a sphere. This sphere will have will be the emitter of the particles. What I want to add is a point bob. In color, random color. So with this simple, just very similar to the normals. Let's add a turbulence noise and position, and let's output these to color. I don't want a 3D noise because I will get different colors. I need only just black and white. And I will promote this parameter for animation. What I will do next is delete the white areas, also by expression and $CR, you already know this. and I will add some extra detail. And what I will do next is to add some variation, some offset. And what I will do is promote this parameter, copy parameter, and paste relative reference on the other two channels. Okay, this will be our particle emitter. I want particles to be emitter and go directly to the center. What I will do next is to import the object that we want to materialize. I have it in an alembic format. Also, it's inside the export folder. It's called this setter. What you notice is that I created an alembic node. This is very similar to the other nodes that we created. It's just for alembic format. It works pretty good. We won't get into details here right now, but for now just bring your object. I think it's on an insane scale, that's why we don't see it. So we'll have to do a couple of transforms, and also it's always better to convert. Polygons and placement. Let's move to the origin and scale it down. It looked like yeah, I had a display also problem there. Okay, let's make this guy a bit bigger. Okay, that's what I want. Probably a bit smaller. So nice, I have my particle emitter and where I want them to go. So let's create now a pop network, and let's plug on our second input our attract object. So let's see what happens. I have a emission there, that's good. This effects works nice with some turbulence. Let's see if the sphere size is okay. And also when I use this kind of effects, I like to add a pop drag, so our particles keep affected nicely. Okay, probably a bit more of particles needed. and also a bigger swivel size. Okay, as terms of random, it's okay. Just you will be able to play around. So rinse and drag. And okay, let's make some place here, and let's create our pop attract. Okay, you have a couple of options here. Goal and force are the two we are going to work. The force scales is well, how strong or not is the attraction. And the goal, you will get different options. The first one is position. Right here you will just get the attraction inside in the zero of the grid. You will see how everything goes to the center. But if we want to bring an object from outside, the first way to do that is to use points. We are not going to set up a subpath, but yes, the second connection input that we are having. And as last instance, we are going to do a per particle, point per particle. So this means that particle 1 will stick to vertex 1, particle 2 will stick to vertex 2, and you get a nice variation . Particles will go to different areas of this setter, of this object. So okay, let's make things a bit complex. What I want to do is to fill the setter from top to bottom. So the first thing I'm going to do is create a delete node, and there's a bounding option here that will delete everything inside that bounds. And let's invert this. So what we want to do is the particles to get attracted only where we have the polygons. What I will also do is to add a level of subdivision, so we have smoother borders. Okay, and what we are going to do is not size but center. Let's make our first keyframe. Let's add our last keyframe, and with Shift let's change the interpolation to a linear animation. Okay, so right now our connection changed, and what we should have now is particle creation from top. Our particles now are going up and getting to this point, and this should go down. Yeah, it's moving down. let's finish just to see him play. Okay, there are a couple of things that are not working. The pulse of the turbulence is a bit strange. Let's set up a higher value, and the rest seem correct. You can probably set up a bit more of a traction. And the last thing I'm going to do is to make these particles collide to our object while it creates. So what I'm going to do, let's skip or bounding box animation. What I want to do is to do another version of this progress, but with a slight change. Let's delete this channel, and what I want to do is add keyframes on first on size and center, but I want to fill the delete just to the bottom to get particles collide in the sector that has been already created. I will also set this to linear. And let's add a collide object. Every time you work with these thin and not volume objects, you may have problems in collisions, because Houdini, what it does, it works with close geometries. It's not as Maya, that for particles it works, it can stick to a surface, so it can collide even though it has a hole. So that won't happen in Houdini. So right now, if we see our surface, we see it has some holes when deleted. So the way to fix that is to add a polycap, that it will add caps to our object and close it in the areas that are open. So right now, if we display our BDB for collision, we will see that we need a bit more of resolution. How I do that? Don't worry about this. We will see collisions also with rigid bodies, with fluids, with flip. This is just a fast intro, but just by going inside volume and multiplying and lower this value, you will get a nice and smooth result. Also inside our pops, we are able to see our collisions. First of all, what I want to do is to use the form geometry, because this geometry is change its topology frame by frame. So right now we'll see how this object is created, and what I can do next is display the let's say the virtual geometry for collision that Houdini creates. Let's hit W to see wireframe mode, and inside collision later let's turn on the collision guide. You will see a collision is happening inside. This might work. You can change this by max axis and right intersect. So this way we can change manually that inside geometry resolution that it's being created. So if you put 75, and also you need to delete this proxy volume. You probably need to rewind, and now you can see you're having a denser collision geometry. Maybe you don't want that much, just low down a bit. But okay, we will see this later on. For now it's okay. So let's turn off our display guide. Yeah, the same thing that we've been doing. What I want to do is to stick particles to our object. Okay, let's see now what we get. We should see some red particles shortly. Okay, I'll change this to wireframe mode and stop particles. Also the animation can be delayed a bit, so we don't have that emission progress. Also some sub-steps are missing. You already know this from the trial, so you can also play around with that. But well, now we see how our object is being created by particle attraction. Let's leave a couple more frames. Let's see how this works. Okay, that's not bad. You can add later on some particle sub-steps. You can change the turbulence. So the idea of these three exercises is just try to replicate them. You can make some nice render of one or the three of them and post them on Facebook. I think that right now you have all the tools needed to make some nice and cool effects. So this is all for now. I'll wait your post from this week on Facebook. Thanks.